That's the water. And then okay. So what's the name of this funnel? Nobody remember what I said 5 minutes ago? Wow.
We have recorded.
Separatory funnel. What we just did is separate. Oh
no way.
This is water. This is organic. We just separated stuff. Hence, separatory funnel.
Well, shoot.
Oh, shoot. Okay, so here is your water. Okay, you just got out. This is the organic layer. This is the organic layer with your precious product. And we keep that over here. We want to get out as much product as possible. So we are going to take the water layer and put it back in here and add fresh ethyl acetate. And we'll actually do this 3 times. So the water layer goes back, and then we take more ethyl acetate, and we're going to do this 3 times. I went up to 40, close to 40, but that's okay. I know, right? Ethyl acetate. And we do the same thing. Shake.
Do I just hold it away? Can I hold that on?
Yeah.
Shake it?
Shake it.
Is this vigorous enough?
Yeah, that's good.
Awesome. I'm doing so great.
All right, so that's good. So you tip it over and put it back in there. And you always remove the top. Yep. And then wait for it to separate out, because again we are using a separatory funnel.
No way.
No way.
So it does what it says it's going to do?
Yes.
Wait.
Think about that. What if politicians used to do that?
That's what I think.
Let's not get political here.
Really
this is chemistry class.
We have a clear...
Really nice separation happening here.
Yeah,
so
clear
this is not always going to be the case. If your separation isn't working really nice like this, what you have to do, we don't have the bottle here, but we have solutions, saturated solutions of sodium chloride. You will have to add...
There it is, the layers.
This is a bunch right here. Saturated sodium chloride solution. You have to add that because it will make the water layer much more ionic and would try to drive the organic away from the water. So making the water layer more ionic using saturated sodium chloride is one way of breaking up emulsions. It's not going to always be like this. You may have to take a spatula or something and like poke it. You guys have seen emulsions, right? I don't know. Maybe you haven't. And poke to break up the emulsions. This one doesn't have emulsions. This one is really nice and clean, but it's not always going to be like this. So do you want to drain out?
Turn it?
Mm-hmm. You could hold it to, you know, to be, yeah.
Stop.
No.
I'm doing fantastic. I actually, it's impossible for you to
Okay, start slowing. Stop, slow. Keep going. Just slow. Wait for it. And stop.
Nailed it.
You could take some more because, yeah, you gotta be, yeah. Nice. Okay, and then put the, yep, there you go. Do you have to do extractions?
I have no idea. I don't think so.
I do.
Okay.
Extraction, that was my favorite episode of Psych, so.
Oh, okay. So let's pretend we've done it 3 times.
Whoa.
Yes.
So so we can move forward. Okay, so that's the normal number of times, is 3 times. We've done it twice. So at this point, you have the water, you have the organic. What you never, ever, 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 ever want to do is to throw any one of them away. Number one, you could have made a mistake. Number two, you may still have product in here, in the water. And you might just realize that at the very end. But if you had kept everything, you could always go back perhaps and recover it and recoup it. So never ever ever throw any stuff away until perhaps you've done the analysis and you determine what you have. Okay? So this is the organic layer, and you may or may not be able to see clearly, but right down here is some drops, in fact like a pool of water. So how do we get rid of the water? We use a drying agent. Of course. So here's the drying agent we normally use. It's anhydrous sodium sulfate. Okay? And what we never ever do, so I'm going to use a spatula. And so I'll show you the different types of spatulas we have. So we have this, we have this, we have this. Whichever one you decide to use is fine. I normally use this one with a nice mouth there to do this.
I like my spatulas having my stuff.
Okay. What you never do, and I've seen college students do this, and it's really insane. This is a lot, and we've had it, you know, all the way up here full. I've seen a college student take this and start like pouring. And like when he's done, half of the bottle is gone, used up. That's insanity. What you do is never pour your drying agent out of the bottle like this. Is to use a spatula is the best way. And you start by using maybe 2, no more than 3 spatula tips of the drying agent, and close it back quickly because it is a drying agent. It will pick up water from the air. And the other end of the spatula, you could start stirring. And what you notice is that it's clumped. Do you see that? Mm-hmm. This has clumped up. That's one way of knowing that you're removing the water. And sometimes, depending, the solution may have been sort of cloudy to begin with, and then you add the drying agent and you could see it becomes clear. I could see maybe a little bit more water, so it's okay to go back and get some more drying agent in there, maybe 2 or 1. But again, not a whole bunch of this stuff at all.
So we dump the whole bottle. No. What would happen if I poured like that down this one?
It'll be just a waste. It's nothing. It's just a waste. All right. So now we have our product in the liquid. We have a salt that was put in to remove water. How do we separate the salt from the liquid?
Vacuum filtration.
Which one?
We filter.
For this one, I would use
Vacuum.
gravity.
Oh.
Because what you're trying to do is collect the liquid to go on to Rotovap, and we'll show you how to do that. The solid you don't want, you don't care for. If, however, and we'll probably try to show you that separately, if your product is a solid, then you're going to use vacuum filtration, because then the liquid goes through. You don't really want the liquid, again, but save it. The solid that's in the vacuum filter, on the vacuum filter, is what you need. And so that's usually the distinction between when you use gravity. You're trying to get rid of a solid that you do not want. Sodium sulfate, you use gravity. All right, so let's try gravity filtration. Anybody knows what this is? What is this?
That's a beaker.
Okay, this is the beaker, this is the flask. This is called an Erlenmeyer flask. So, let's do this the proper way. Anytime you're setting up stuff, especially with glassware, you want to secure the glassware. And this might seem trivial for the gravity filtration, but it's a good habit to have, is to secure the glassware using this clamp. And what else do I need to do the gravity filtration?
The actual filter.
Filter paper. We got gravity. That's been supplied. Okay. You don't need to turn that on or anything like that. So yeah, for filter paper, for the gravity, you bend it into half, and then another bend into quarters, and then you just open up one side like this.
Beautiful.
Okay. And then you pour. Now, having said this, if you are pretty good, and you don't even have to be pretty good at this, you could do something that's called decanting. And it simply means this stuff is going to stay at the bottom, basically, and you could just do this, right? And pour it out. If you're very careful, right? So that's an option. Decanting the liquid away from the solid, or more traditionally, just doing a gravity filtration. So either one of these could get you to the same point. This one gets you to the point where you're one step away. Basically, you're there for doing the rotovaping. Yeah, there's a lot of ethyl acetate fumes around here. It's like going into a nail salon or something. All right, so sometimes you might have a stir bar, stir bar in the way. Either like in here and you don't want it to get into here, or when you pour in here. To get rid of a stir bar, you use a stir bar. Okay. Retriever. So sometimes you may have to do that. This is almost done. So if you use this method, then you would have to then pour your liquid. So this liquid now, this organic liquid, this organic solvent, should have your product in it. And we are going to do rotovaping. Okay? So we've done extraction, we dried it, we are filtering it away from the organic layer, away from the drying agent. And depending on what you did, you then need to transfer it to a round bottom flask. When you're doing this, you never want to fill the round bottom flask all the way up. Maybe 2/3 is good enough, because you do not want this to like spill when you're doing. That's about good enough, and you just have to put the rest in later on. Okay? So we never fill up the wrong bottom flask when we are doing vacuum filtration. When we are doing rotovaping, sorry. All right, so here's the rotovap. Again, you guys that are far away, you probably really need to come, especially if you're going to be doing rotovaping. So the first thing you want to do, so rotovaping is just evaporation, because you have your product in this liquid. The product is in here, but there's a whole bunch of solvent. You want to get rid of the solvent. You want to evaporate the solvent away. The first thing you want to do when you get to the rotovap is take this off. Okay? You take this off, it's on here, take it off, and you clean it with water, because again, you do not want whatever was, even though it looks clean, it may not be. You do not want whatever was on here to contaminate the product, your precious product. And water, I usually always do water first, and then an acetone rinse next and last. Okay, that's all it takes really. And cleaning this is something you do always before, and when you're finished, you always clean it as well, leave it clean. Okay? It's not necessary to use this clamp, this clip, but you could.